think the AI investment is scaling so fast and the size of these AI supercomputers is getting so big that copper is no longer cutting it and they're starting to include optics.
The demand, for the bandwidth that's carried over photonic circuits is growing at a rate that just has never been seen before in the history of mankind. So if anything, people have underinvested in bandwidth historically, not realizing how important it was. And what the industry really needs is this tenfold increase in capacity between GPUs talking to each other.
If we learned anything from Moore's Law over the course of the last 55, 60 years, it is that integration is inherently a very, very, very good thing. For optoelectronic systems and package, integration is absolutely key, and now is the time.
Silicon photonics can really reduce the power by a large amount and really kind of address that problem. Because that is the big problem of our times, really, energy, and ensuring we can save and harness and maximize energy usage. And silicon photonics can address that.
I think photonics is going to play a really critical role to enable larger scale clusters of AI systems to be able to go outside of single rack systems into whole rows of GPUs and XPUs to be interconnected through optics.
So we need to scale up silicon photonics to very high volumes, and here we get an appreciation of what these volumes are going to be. So they're looking to hundreds of millions per month.
There are richer interactions from photonics that is beneficial for compute. So it may be a bit longer out, maybe 5-10 years out. There's going to be an awful lot of optical compute, I believe.
That collaboration, that atmosphere that we saw today, that's what we need to overcome still some of the challenges, especially in the manufacturing, the scaling, and the testing and the packaging, to really make this blossom into the future and show the whole world what the uniqueness of this technology.